Hey guys, okay, so now we're going to look at, forgot the name. Here we go. F6, understanding negative exponents, okay? So understanding negative exponents. So again, before you do anything, time out. Before you do the problem, what do you notice, right? What do you notice? And give yourself time to think about what you know, okay? So, what you know, what do you notice? And then look for patterns, okay? So again, you're trying to master this, right? You're trying to get this into your memory so that you really keep it there for a long-term memory so that you can do well in your interim and also for your SBEC, okay guys? So let's go ahead and do these problems. So again, you're gonna go to F6, understanding negative exponents. Okay, so here we go. Remember that a negative exponent is just a very easy short way of saying that you have a small number, very small number, right? Like the size of a bacteria. That is so small, right? It's not greater than 1. It's way less than 1. So a negative exponent actually means when you're less than 1, isn't that a decimal? And then if you're a decimal, isn't that a fraction? So if you have a negative exponent, that means you have a very small number, right? That's number sense, right? How much, right? Very small. So now the thing is, nobody likes to work with 0.000000000, right? You want to work with small numbers, but in a very easy way. So negative exponents help us to do that. So remember that negative tells you two things. One, it tells you that it's small, very small. The second thing it tells you is that negative means opposite, right? Remember that? So negative means opposite. So remember, in a fraction, you have the numerator over the denominator, right? The numerator over the denominator. So keep that in mind. If my number is negative in the numerator, where does it want to go? The denominator. If it's negative in the denominator, where does it want to go? The numerator, right? So opposite. So you see the negative, that means go opposite. So depending on where your negative is, you go the opposite. So that's the concept, that's the idea. Now be careful, let's see what they do here. All right, write the expression as a whole number with a negative exponent. Okay, so again, no fraction. They just want a numerator. And therefore, you're going to have a negative exponent. So do you notice here that there is a fraction? We don't want fractions. We want to rewrite this. Equivalent, right? What's another way to write this? But as not as a denominator, no fraction, right? I want to get rid of this. So if the 7 is positive down here, right? How do I go opposite? Negative, right? I make it negative. So here we go. I want a whole number. So you're going to choose this one, not this one, because that means you're going to give me a fraction. It doesn't want a fraction. It wants a whole number with a negative exponent. So we're not going to do this one. We're going to do this one. Let's delete that. So here we go. So we have, if the 4 to the 7th power goes to the numerator, so there it is, 4. Wait, do I have an exponent here? So we have a 4, then you click that, I guess. It's not to the 7th power, right? We went opposite, right? We took it from the denominator and we put it in the numerator, and there it is. That's a whole number, okay? So I don't really think I need to draw anything here. So we have what? Let me zoom out here, of course, because this pen is finicky. So we have 1 over 4 over 7. That's a fraction. We don't want a fraction. If this is positive in the numerator, right, it's happy. That's a smiley face. It's happy, right, in the denominator, and it's positive. I don't want to be here, right? I want to throw it to the numerator because then I'll have a whole number and I'll get rid of my denominator. So when you throw it to the opposite side, boom, right there. You showed me that you did opposite. Okay? So 1 over 4 to the 7 is equivalent to 4 to the negative 7. Do you see how this is a whole number? It looks like a whole number, doesn't it? But that negative tells me it's a fraction. Okay? So equivalent, put that in your journal, right? What does equivalent mean? It means equal or the same, right? So on the S back, this answer and this are both equivalent. They're the same thing. But this one is written in fraction form, and this one is written in what you would call whole number, because there's no denominator, okay? So again, negative tells you two things. It's a small number, so you know it's a fraction, but we don't want the answer in fraction form. We want to change it, right? Give an equivalent answer, but in a whole number where there's no denominator. So if you're in the bottom denominator, you want to go to the numerator. So that means that you got to change the sign to tell me that you went opposite. Okay, let's go ahead and submit this. Is this going to work? No, it's not. Submit this. Boom. Okay. Again, if you get it wrong, ooh, look it. They're going to test you on everything now with negative exponents. I want to know everything that is equivalent to a to the negative 2. So what you do here is you write out all your positive, not your positive, all your ways to, oh, there's got to be a way to delete all this without, pause that. Okay, there, I deleted it. So, okay, did you see that problem? It was 8 to the negative 2. So think about it first, right? What do you notice? 8 to the negative 2. Well, do you notice that the exponent is negative? What does that tell you, right? It tells you that it's a small number. So what's a small number? A fraction. So that means that if it's a negative exponent, you can rewrite this as a fraction because that's what it is. So let's go ahead and go to our tools. Let's zoom out as much as we can, and let's do this. So let's start with the original problem, 8 to the negative 2. I can't evaluate negatives, okay? You can't answer that. You have to make it into a positive before you can give me an answer. So isn't that equivalent? Again, equivalent. Isn't that equivalent to, where does it want to go? If it's in the numerator, it wants to go to the denominator. So there's my numerator, it wants to go to the denominator. So 1 over 8 over 2. Now it's positive because you went opposite, right? That means opposite. So if it's whole number, it wants to go to the denominator. So now can I evaluate this? What's 8 times 8? 8 times 8 is 64. So look at, here's an answer, 8 squared. That's equivalent to 1 over 64. All right, let's go check everything that matches. Oh, this is going to be tough. You're actually going to have to go through this. Hey, look at, this is equal to this, which is equal to what? 8 to the negative 2, right? Isn't that where we started? These are all equal answers. So boom, there's one answer. Okay, we made it into a fraction, but look at, wasn't it supposed to change to opposite? Look at this one. It's still negative. Why is it still negative? If I started with a negative and I went to the denominator, this should be positive. So that is not an answer. The heck? Okay, next. Oh, you guys can't see the pop-ups. Okay, cool. So here we go now. Look at this. Can you clean this up? Okay. Can I scroll here? Okay, so that's negative exponents. Now you're going to use what you know. 1 over negative 8 to the negative 2. Oh my gosh. All right, let's see what we can do here. This whole thing, this number needs to go opposite. Let's do it. I'm going to throw this to the numerator. So take your parenthesis, negative 8, and opposite, right? You made what opposite? You made this. It was negative down here, but if I throw this number to the numerator, right? Here it is, numerator. What's in the denominator? A 1. Okay, but we don't need this, right? Identity property. Now, what is this? That's just negative 8 times negative 8, which equals positive 64. Now hold on. Is my answer supposed to be 64? Or is it supposed to be 1 over 64? Are those the same thing? No, this is $64, right? This is 64 hundredths, right? Or, sorry, 64, yeah. So, let me see here. Okay, so, yeah, that's not hundreds because you don't have a third place value there. Anyway, those are not equivalent, right? So again, you have to be so good with your rules, right? That negative on the bottom told that whole number in the parentheses to go to the opposite numerator. And so negative 8 times negative 8 is 64, which is not the same thing as 1/64. So that's not an answer, right? These might be a little bit tougher, so you're actually going to have to figure these out. Now, careful, this is a negative outside. So you already know that this is going to go to the top, right? So you know that that's going to be a 64 on the top. That is not an answer. All right, here we go. Let's exit here. What did we say? That's a good answer. That is not a good answer. And that is not a good answer. All right, here we go. Evaluate. You actually have to do these, okay? So do the first one. All right, so here we go. Okay, what do you notice? Do you have any negative exponents? No. You do have a fraction, so you do know that it's a small number. So you also know that you can change that to a negative exponent whole number. So let's go ahead and look at that. All right. Let's evaluate this first. What does this equal? My gosh, this pen sucks. It's 1 over 3 times 3 times 3 times 3. Hold on. How many threes? 9 threes, right? So 3 times 3 times 3 times 3 times 3. That's 5 times 3. That wasn't 5. I lost my count. Okay, 3 to the, let's see here. I have to write it out. Again, you guys are going to have calculators. 3 times 3, that's only 6. 8 and 9, okay? So 3 raised to the, okay, so I had to use a calculator for that. That's 1 over 19,683, 19,000. Okay, so now I know this is a fraction, right? I know that I can rewrite. What can you do when with 3 to the 9th power? If it's a fraction, how do you change this to a whole number? Don't I want to throw it to the numerator? So if I put this positive into the numerator, then you go opposite. So denominator to the numerator. Oh, that's 3 to the negative 9. Okay, so that's definitely this one. Okay, is that the same thing as negative 3 multiplied 9 times? Ooh. Okay, that's a tricky one. You'd have to actually do it, right? You'd have to do negative times the negative 3 times the negative 3, negative 3, negative 3, negative 3, negative 3, negative 3, negative 3. And here, let me tell you something. That's positive. A negative times a negative is positive. That's positive. A negative times a negative is a positive. That's positive. A negative times a negative is a positive. That's positive. So positive times positive times positive times positive is positive, times negative is negative. So I know that my answer has to be positive. I never got a negative answer, so that's not it. How about this one? Same thing, right? It's 3 times 3 times 3 times 3 times 3 times 3, right? But there's a negative outside, no parentheses. So that means that it's a negative answer. My answer is not negative. Ooh, look at this one. This equals, it's a negative exponent. I gotta make it positive. Let's see what this turns into. Let's see if it looks the same. negative 3. Keep your parentheses, don't lose them. That's your number, right? That's your whole number. And it's got to go opposite. So it wants to go to the denominator, right? And guys, didn't we already figure this out? This is just going to be a negative 19,683. A negative? We don't want negative. We want positive. So that's not an answer. Take a moment to think about that, okay? All right, this is probably the longest tutorial, but that's okay. Okay, there's my answer. That's the only one. All right. Ooh, equivalent. Okay, so write the expression as a fraction. Okay, I'm glad we got this one. So we actually want this in a fraction. It's negative and it's a whole number. So I want a fraction. That means I want a denominator. So in the denominator, it's going to go down. 7. Oops, I am in a denominator form. Let me see here. So it's going to be 7 to the 4, right? Because it went opposite. It was a whole number, numerator. It's got to go to the denominator. Turns opposite. What stays here? A 1, because there's a 1 right here. All right? And let's get it wrong. Let's get it wrong. Because I want you to see the explanation. Right? Look at that. Here's the rule. Anything to the negative power turns positive. All right.